Should put the headphones on. Fuck it. Okay. This is the crimper tool. Yesterday we were talking about getting the crimper tool. I finally fucking pulled the trigger, man. I thought I was gonna get a regular ass crimper tool for insulated wires, but I ended up buying this fucker right here. Now this fucker right here is not a Chinese secondhand or whatever the fuck you want to call it crimper tool. This is, I don't know where I put the packaging, but that shit, oh yeah, it's a Knipex. It's made in Germany. Now you know what Knipex stands for. It stands for emptying your bank account faster than you can fucking think, or say, oh no, actually I didn't mean to buy this. It was a mistake. You get to the cashier and you put your credit card in and she says 183 euros. And you buy it. That's what happens. It's made in Germany though. So I'm guessing it's pretty good. I'm hoping. So we're gonna see. Basically, yesterday we haven't done anything worthwhile. What we've been doing is we've been crimping some wires left and right so that we can put them in the power supply for the light reactive installation for Monaco. Okay, for people who haven't seen the previous streams that are watching the replay, this is a light installation that I'm currently working on for the Principality of Monaco. It is basically a maquette, so a smaller version of the country. A big ass table. It's gonna be 90 centimeters high, 1.5 meters long table by 80 centimeters deep. What's gonna happen is all of those little cuboids, which are rectangular cubes that you see over there, are lit from under by LEDs. So it looks very fancy, it looks very Apple-like, Tim Cook, as I like to call him. And whenever there's an event that's happening in Monaco, the place where the event is happening is going to glow a different hue. It's going to like wave out. Eventually, I'm thinking also of doing other installations for that. So little add-ons, so an NFC tag, you can put your phone on, see the location, see the map, where you have to go for it. It's gonna be great. And so first day, we started working on the cuboids, and we tried epoxy, so resins. That shit didn't work very well, so we ended up discarding the idea. So we poured resin into steel tubes. I think I still have them here somewhere. Yeah, there we go. And as you may see, the resin is still in the tubes. You can't get that shit out, even with like the molding agent and stuff. It didn't work. It didn't work. So we pivoted. We pivoted to what? We pivoted to acrylic. Now, acrylic is those little fuckers, solid cuboids that I sanded post-processed with different grits. So I have 4 of them. They are right behind the fucking computer, obviously. I didn't think that through with my head. Whoop. Okay, there we go. All right, here. So we have this little tiny installation that I made a couple days back. And basically it is a miniature version of what we're actually going to work on. All the little cuboids, you shine a light from under. I don't have the LEDs yet. And yeah, that's pretty much the state of the project right now, is this. Hey, we're pretty far off, man. We're pretty fucking far off. Now the goal of the entire thing is going to be to make this happen within the next couple weeks, maybe month. And right now we're pretty far from it. So that's why I'm streaming daily, and this is day 4 of building this contraption. So today on the menu we have a bunch of electronics because the thing that is going to make this whole contraption happen is electronics. Good thing, it's my favorite part of the build. Sponsored by Knipex. So what we kind of went through it yesterday. I'll make a very short version. The entire circuit is going to be as such. I'm gonna put that right here. Yeah, that's bigger. That's way too big, actually. Wait, there we go. Okay, pretty much. So what's gonna happen is we have a plug that is gonna be plugged into the wall. This has a fuse for security. This is alternate current, AC. So we're talking 230 volts. Is going to be fed into this power supply, which is going to output 24 volts. Not only one, but two, baby, because when you turn 230 volts to 24 volts, the amperage is going to be much higher. So I don't want to fuck up. So I got two power supplies just to be professional, as we say. Then this bench power supply, not bench power supply, regular power supply, 24 volts power supply, is going to feed that energy, that current, that electricity into a fuse box. So why a fuse box and what is a fuse box? This is an automotive fuse box. Fuses are little things that burn if the current gets too high, basically. There's more explanation on the stream yesterday if you want to check that out. It's available on the YouTube channel. And you put those little fuses in there, and if there's too much current, it basically blows the fuse instead of your LEDs. And then that electricity is going directly to the LEDs, and we control the color and the light of the LEDs with a bit more advanced electronics that we're going to do today as well, coding. Raspberry Pi, which is going to be the brain of the operation, is going to be connected to the internet so that I can feed all the data of the events into it through internet, so I don't have to go to the installation to actually update it. And it's going to communicate with two ESP32s. Those are tiny little baby computers that are going to send the information to the LEDs, what to light up and when. All right, so this was pretty, that was a real shortcut of the entire thing. Yesterday we handled a bit of crimping. Crimping is putting connectors at the end of wires to go from the power supply to the fuse box, but it ended up that I didn't have the crimping tool necessary to do the rest. And so this morning I went and kind of spent the entirety of my monthly allowance on this tool, which we're gonna use today. That's fucking epic. Okay, so plan today is number one, finishing the wires that go from the power supply to the fuse box. Number two, finishing the wires that go from the fuse box to the LEDs without the LEDs. That might be number three. Actually, number two, which is before, is going to be coding this and this, the interactions between the two. How are they going to interact? That's the last part of the equation. Through a switch. What is a switch? It is basically a hub. I'm not completely sure what I'm talking about. It's basically a hub where you connect multiple Ethernet cables and you can make a local network, and they basically connect, they talk through that. Through a protocol that is called UDP for large data packet sending. So, crimping, it's crimping time. I haven't crimped with that yet. I bought it this morning. It was a couple hours ago since I bought it. So we're going to do a bit of testing, testing the real fucking basic of that. Let's try. Whoop, 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 whoop. Okay. Yeah, bud. Okay. 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 All right. So, how this works. You basically take the connectors. So for this, those are the ones that are going to go from the power supply to the fuse box. The fuse box has those terminals, which are basically bolts, nuts and bolts. And the way we're going to make the wire go to this bolt is with those ring terminals. So basically, this little fucking fucker. Wait, actually this setup is horrible. What the hell? Yeah, let's do that. Let's do it. Yeah, like this. So basically with this, this is going to put itself around the ring, and then you put the nut back on, basically. As such, with the washers as well. So, to crimp a wire, you need three things. You need a wire. you need a stripping tool. So you basically put the wire in there. How do I show this properly? You put the wire in there. You make sure to expose enough. I'm not sure I'm exposing enough. As I said, I haven't crimped with the other tool, so we'll see. And then you press, and it takes the insulation off and just leaves the bare wire exposed. Now, the way we're gonna do this, we're gonna put this in, and there's a little metal part in there. Yep, that's pretty much all right. It's going out a bit. It shouldn't, but fuck it. And so the insulation stays in the other insulations and the wire gets into the metal. And then the idea is that with our beautiful, beautiful 183 euros or 6, I don't remember exactly, tool, we're going to put it in there. And I'm guessing around here, maybe a bit lower, yeah, around there. And then press, right? All right. Okay, that was the wrong side. Well, at least we learned. Okay, so you don't put it in this direction, like this. You should put it like this. That's good. I have a bunch of connectors. I bought a shit ton just because I knew this kind of things would happen. So back in, put it in there, put the metal part into the metal part, and you put it into the crimper, and hey, epic, okay. And we go, whoop, no, wait, what the fuck is going on? Okay, yeah. Unratchet it, put it in there, sideways, if I understood correctly this time, and Jesus fuck, it's not working. Okay. I'm doing something wrong. Maybe it's the wrong size. I don't think it's the red, is it? No, it's the blue. Is it though? Okay, we'll try again. We'll try again. It is a learning curve. I'm not a fast learner, apparently. I always thought myself as a fast learner, but apparently I'm not. Okay. Put the wire inside. Get it in there, all the way. Shitting fuck. Come on. And AWG 20 to 10. Yeah, that's what it says. AWG 20 to 10. And this is AWG 14 wire gauge. Put it in there. Ah, fuck. Ah, shit. Oh, Jesus. Okay. Let's try like this. Let's put the connector in there to begin with. Get one crimp in, one ratchet click in so it doesn't go out. Put the wire in. And fucking press it. Oh yeah, there we go. Oh, that's not going anywhere. Hey! Got it, first try. I'm genuinely not sure it's this way though. Let's try the other way again. Because it looks fucking weird. You see? Like it goes up compared, like the ring terminal's there and just like goes up. Let's try the other side again. Because I'm not sure it was good. Wait, does that fit in there? Oh yeah, it's perfect. Okay, because I got M6 as well. But M5 is what I've been using. Okay, yeah, no, it's fine. All right, that looks pretty straightforward. It's gonna take me a couple of a few minutes to go through that, but let's fucking go, bitch. Whoop. Oh, that's way too little. Whoop. That's still too little. Whoop. Okay, that should be fine. No, it's not fine. It's too little. Okay, this should be good. Whoop, put it in the connector. No, put it in the crimping tool. Fucking close it up with one ratchet thing. Let's try this side now. One ratchet, click. Put the cable in. All the fucking way now. Put the cable in. Yeah, cable is in, and press. And, oh yeah, that makes much more sense. Oh, that's way prettier. Okay, so we figured out that, so those are my 2 attempts. This looks prettier. So in the same size, the crimp happens in the same places, in the same axis as the ring terminal, whereas this is like high and then it's long. Okay, 2 down, 17 million to go. Because then all of those pins individually, I'm gonna use AWG20 wire, but all of those are also ring terminals. So that's gonna take a while. Oh fuck. I'm fucking stupid. Okay, wait. There we go. 1, 2, 3, and the bolt, nut, the nut. Okay, next. This is way too long. There we go. We are crimping. That doesn't work properly, does it? Yeah. Put this shit in. Go for it. 1 ratchet click. Put the cable in. Pray for it to fit. Push it in a bit violently. And then ratchet. And take it out. And that baby is crimped. Epic. 3. That was all my positive. No, I had 4. All right, there we go. Wait, I didn't even connect it for this one. Did I? Maybe I wasted this one. What the fuck happened? Oh, there it is. Yeah, this one is like a throwaway. Okay, yep. So, strip it. Should be good. Just take everything out of the fucking, yeah, there we go. I wasted 2, which is a reasonable number, to be honest. One, put it in. It's not going in. It's in. And it's solid. Give it a little tug. Next. Whoa, Chinese sweatshop vibe in there. Let's go. Let's keep going. I think some people do that all day, every single day. I wouldn't be an electrician, even if you paid me money. Well, that's kind of the point of being an electrician. You would be paid money, wouldn't you? Oh, okay. There we go. Put it in there. And crimp. Whoop. Give it a little tug. All good. It's only been 20 minutes. Ooh. Let me see if I can go on the creator dashboard and Steam. And check. Oh, give me a second. Stream manager. There we go. Edit stream info. Oh yeah, there's no title. That's what I thought. Sorry. Give me a second. There we go. Yeah, I just didn't have anything on Twitch for Monaco Day 4. Category, Science and Technology. 139 viewers. Wow. Tags, English, Electronics, Art, Raspberry, Raspberry Pi, and Tech, and English, rerun, no, done. There we go. That's a bit prettier. That's a bit better. Epic. Okay, all right. So where are we? Yeah, we need three more crimping wires, 3 more wires to crimp, and once those 3 are crimped, then we can keep going on to the next task, which will be actually connecting them to the fuse box. And once that is done, we can actually start working on the AC part of the circuit, the alternate current, to actually power the power supply, and then connect the power supply to the fuse box and see how this fucking works. With a multimeter, we can check if we actually have the outputs that we want on all of the pins. We're gonna do all of the pins today. And so, not all of the pins. I have 14 channels of LEDs and split among 2 different fuse boxes. So what's going to happen, it begins completed, sorry, is we're gonna do all the channels needed on the fuse box and all the channels needed on the other fuse box. I have 2 power supplies, 2 fuse boxes, which is gonna take a bit of time. And then once this is done, AC, power supply, fuse box, we're gonna start on the coding and the routing. So I have the switch. I have the switch right here. We're gonna try to connect the Raspberry Pi and the ESP32s to the switch and see how that is all going to work. This is fucking exciting. I'm really excited about the project. It's gonna take a shit ton of time though. And clip. And put that shit in. And ratchet that bitch. Whoop. And tug to check, all good. Next one. There we go. I might need a bit more wire for this. That should be fine. I don't think anything changed, but you know. Ah, fuck, I'm missing one. I think I bought a shit ton today. They should be around here somewhere. Yeah, there they are. Yeah, I got a bunch more. Those are spades, which are different connectors. Those are ring terminals, but red. I don't know what that means. And those are also red ring terminals. Ah, shit, wait. 4.3, 4.3, 4.3. That is not what I want. Those are M5s. Ah, fuck, I think I'm missing a couple. Oh, it's okay, I can just try with one PSU. Okay, yep. There we go. Fucking crimp that shit in. And then we can get started on doing the AC. Which, I've never worked with alternate current before, so I might die a terrible death live streaming, which would be entertaining in its own sense. So I'm kind of looking forward to that. But I made some research yesterday. So for the stream yesterday, what we did is we did a bit of research on AC and on the cabling and make sure that everything is safe. There we go. So now we have all but one cable. This one is missing a connector. I don't think I have any more that are usable. Actually, I could maybe use those runs that I did earlier. They're really bad, but let's try. And whoop. A bit more. Whoop. There we go. I'm not sure it's gonna work, but I can try. You know, trying is always appreciated. No, it doesn't fucking work. Okay, I'm gonna need to buy more tomorrow. Epic. It's not like I've bought a gazillion things already. Okay, so let's make a bit of clear here. Let's actually, no, this is AWG 14, which means it's 2.5 square millimeters. So I don't think it's gonna fit in there, but you don't know until you try. Oh, you know, there's no fucking way. Oh wait, no, it does fit. That's sick. But I think the ring, yeah, the ring is too small for it. Those are 4.3 millimeters rings, so M4. And I don't think I have any red, oh yeah, I have red ones with M6. I think I can do it with that. I don't think it's dangerous per se, because most of the wires are going through. So let's do that. And M6 is a bit wide for this, but I say fuck it. More contact is better, I guess, I don't know. Plus it's for the grounds part, so we should be golden. Yeah, there we go. Yeah, it fits. It's not perfect, but it fits. I need a bit more wire to have the most contact possible. Yeah, it's gonna fucking do it. Yeah, fuck it. Let's take this fucker. It's red though, so red goes in there. There's two. Put that shit in. Pray and hope for a good outcome. Push it all the way. Crimp the fuck out of it. I crimped it wrong, but you know, yeah, it fucking works. Fuck it. All right, so now the concept is the following. I have two longs, and the two longs are paired with the two shorts because the position of all of my electronics is gonna be precisely calculated, and I did the measurements yesterday already. So instead, since this is the ugly one, I'm gonna take the other pair. So two shorts with two longs, there we go. So the fuse box is set up like this, in the sense that it has plus terminals and minus terminals. So what we're gonna do is we're gonna unscrew, well, the minus terminal is the only one that's available. Get all the washers out. I think I'm gonna put a washer at the bottom. This is kind of exciting. And put one of the screw terminals on there, the ring terminals, and the other on there. And put another washer on top. And then screw all of that shit so that they are constantly in absolutely perfect contact. I don't have anything decent to screw more, but I can use that. There we go. And that is the minus. I put the reds on the minus. All right, so let's do it again. Take the nut out, take the washer out, take both of the ring terminals out. And since we are on the minus terminal, we shall put the black wires. This fucker, and let's go. Whoop. That looks pretty good. So we have, right. So we have both of our black wires that are connected to the fuse box. This is the ground, and now we will do the same for the plus, for the 24 volts input that are going to power the LED strips. LED strips that take 24 volts. We talked about it yesterday. Why do they take 24 volts? Because if you give 5 volts to LED strips, they're gonna ask for more amperage because they pretty much all have the same amount of wattage, the powerful ones I mean. So for an LED to be powerful, which means to have a lot of light, a lot of, I don't know which is the unit, if it's lux or lumen. Either way, oh fuck, hi. Either way, this is getting absolutely out of control. Either way, yeah, okay, yeah, you're fucked. Wait. I kind of strapped it and it's not happy. Yeah, either way, for a LED to have a lot of light, you need to give it a lot of electricity, a lot of wattage. So they all, the powerful ones that I saw, all kind of get the same amount of, what are you looking at, the outside? Yeah, it's fucking sick. All of the LEDs that I found have pretty much the same amount of wattage needed. And since watts are volts times amps, to compensate for the low voltage, if you take 5 volts LEDs or even 12 volts LEDs, you are going to need to get a lot more amps, and that's what creates heat and overall potential damage. So having 24 volts LEDs is just a safer bet for me. So that's what I'm doing. So that's why I got 24 volts power supplies. There we go. Okay, washer at the bottom like we did earlier. Whoop. Then 1 cable, 2 cable, other washer. I think this is like a screw out preventer. It prevents the nut from screwing itself out. I'm not completely sure, but it's on all of them and it's always on top. So I'm gonna guess that's what it is. If it's not, it's fine. And yeah. And so this baby is now fully stocked on fucking wires, which is necessary for its good functioning. And it's gonna take 24 volts inside of it. Hell yeah. Now, since we have the fuse box with the wires, let's do the other one. I have another fuse box. All of those fuse boxes have little plastic covers, which is extremely useful because 24 volts can be dangerous if I'm not mistaken. Even with like dry skin, you touch, you get zapped. So plastic covers is more than welcome. So here we have the second one. I never know how to open this, and I hurt myself multiple times trying to open them. There we go. Second one. So we're gonna connect all of the wires to it. Whoop. Okay, connect the wires to it. So, unscrew all of that, put in the wires like we did with the previous one, and then we are good to go. We have the fuse box connected, and then we're gonna do the power supplies. Power supplies, 24 volts, fun time. Since we now have all of the tools required, which was a nightmare. There we go. And perfect. Now we're gonna put the wires on there. Where are they? Over there. There we go. So a pair of long positive with short negatives, because the positionment of the power supply is already known for the final project, so we don't fuck it up. And I forgot the washer on there. Classic. Put the other washer on there as well. Whoop. And put both of the wires on there. Washer on top. Thing that makes sure that it doesn't unscrew. And connect the fucking nut. And we are golden, baby. Boop, boop, boop. Okay. Connect that in, screw that in, and then we have what we need for the power, for the safety. So fuses are necessary, otherwise if there's a current surge, even a voltage spike, I'm not sure how those things work. But anyways, if there's too much power going through it, instead of the LEDs burning, it's going to be the fuses that are going to burn. The fuses are little things that look like this. Those are blade fuses. They're used in cars. Which is pretty cool. Actually, I'm using fucking car parts for an installation. And you basically plug them in. Whoop! And then the current goes from the 24 volt input all the way to the ground, and then gets split along the way based on what is required by all of those channels. But if there's a power surge, like it requires too much and it knows it's gonna burn, then the little wire that's inside of the fuse is going to burn instead of the LEDs, the wire in the middle, right? I think that is a pretty cool use of of technology. All right, I should have just said nothing if it was to say this. All right, next one. Boom, boom, boom. We got the 2. This one is way too big. It's like M6. But the washers are going to do their job here. So even if it's way too big, it should be fine. Because there's a lot of contact either way. Now, the covers, we looked at them earlier. They cover quite a bit, but there's still a bit of metal. So if you really want to go touch it, you can. So I'm gonna have to be wary of this, especially since this one is a bit bigger than the rest. It's M6 on an M5 on an M5. An M6 on an M5, which is a bit too big, but it was the last connector I had. Okay. We're super safe. I think this is the safest fucking electronics I've ever done in my entire life. Oh, that's not what I want to do. That's what I want to do. Yep, okay. So now we have all of this connected. We can start looking into connecting it to the power supply. So this is the power supply. This will supply 24 volts to the circuit. And it has little screw terminals on it. So first things first, I think we're not going to connect the fuse box straight away. We are, however, going to connect the AC part of the circuit. Oh, it's the wrong side. Whoop. To make sure, first of all, that the plug that we have here works properly with its switch. It's grounded. Okay, all right. So this is the ground. This is, I checked yesterday. So if you look at the cable, which plugs into there, it's this one. You can see it is shitting fuck. You can see it labeled, right? So there's ground, well, you can't really see, can you? Oh, there we go. You can see it's labeled. So there's ground, line, and neutral, which are the 3 points of AC electricity in Europe. I'm assuming it's the same in the US. So we plug it in, and this plug's idea is that it will filter electromagnetic interferences, and it also has a little fuse inside of it in the middle. So if anything fucks up, this will burn and this will stop working before burning my circuit. There's also a safe switch, which is always welcome. And this is the encasing is metal, I'm guessing aluminum. And so you see both line and neutral are connected to plastic, but the ground is soldered. Yeah, that's soldered onto the encasing. So the encasing is going to be grounded. So even if we touch it, it shouldn't be a problem. I'm not going to touch it either way, but theoretically, it is safe. That is something that is done to a lot of encasing of whether it's large-scale installation or anything. As soon as you start working with AC, or even DC at high voltage, to be honest, you generally tend to ground everything that's metallic, that's touching. Even if there's no perceived risk, you generally tend to ground shit so it doesn't zap the users, right? So what we're gonna do right now is use those connectors, which is another type of connectors. I think they're the right size, I'm hoping, to connect another pair of 3 wires to this fucker, right? So those are called spade connectors, if I'm not mistaken, and this is that's the right size. Yeah, it's the right size. There we go. And you just connect it like this. And you just crimp. The installation just broke off. Hey, okay, wow, I bought really good shit. Okay. I'm gonna use another one. I think this one is compromised. So I have 3 different wires, 1 for each. Oh fuck, the entire camera. Oh, you can look. Yeah. This camera can just look at the current setup. Look at that. Isn't that pretty? Yeah, I think it's fucking pretty, man. Hey, all right, sick. Whoop, whoop. Okay, so what we're gonna do is, so I have, I shouldn't put this in my mouth, it's been in China too long. I have this, so those are the connectors that are gonna go into the screw terminals of the power supply that I have right here. And on the other side, I took the insulation off. Those are 75 centimeters. I cut 75 centimeters out of it. I think I did it for the red and the black as well, but I'm not completely sure, so I might have to redo it. And so, just like the one before, this is a bit too much. Jesus Christ. There we go. This is a bit too much, so just like the one before, we want, this is still a bit too much. Fucking. There we go. This is fine now, isn't it? Yeah, it is. Just like the one before, we put the wire into the connector, and we are going to use our extremely overpriced tool to crimp it up. Yes. On this side, right? Yes, buddy. Okay. And crimp. Did it do the job? It did. It moves a bit. Shouldn't be the case. Let's recrimp it. Just out of safety. Yeah, it doesn't move anymore. Sick. Okay, yeah, there you go. So it is crimped in there, which means that it's not gonna get out anytime soon. And the other side is crimped here. So this is the ground. Anyways, so we can basically connect it already and not risk anything, even if we start plugging the rest in already. So there we go. This is connected to one, and this will be connected to the ground input of the power supply. So if we get a beautiful, beautiful screwdriver, which should be somewhere here, yep. Makita, baby. Yay. Okay. Fuck it, yeah, this one, yeah, sick. Whoop. Ratcheting screwdriver. Your mom's jealous of it. Whoop. There we go. And so you see there's a screw and there's two plates. I don't know what metal this is. And basically you put your little connector in there and you screw it in. That allows for very secure connections, which is what we want. Okay. Whoop. Ground. It's not unscrewed enough. Ground. Screwed back in. Relatively tight. That shit's solid. And so this entire thing is extremely solid. We got the plug with the little switch and the power supply. And now we just have to do line and neutral, which I am kind of scared about. But I don't see where there would be anything going wrong with it. Now, we need, I decided to use red and black. Normally it's any color that you want for line, and neutral needs to be blue. Those are the conventions, but I happen to be making my own conventions. Now we need the exact same size, which is why I am moving in a very questionable way, because I'm going to take this red wire, take it there, and kind of match the size around here. A bit more because it was a bit twisty. And snip. And take the red, take the black, and do the same thing. I need water. Whoop. Match the size. And snip, circumcision. Whoa. Okay. This goes there. I don't need it anymore. I am back. Okay. And we denude it in a very respectable fashion. Would you mind getting naked? Thank you. We denude this one as well. Excuse me, would you mind getting naked? Thank you. I might need a bit more. Yeah, it's around 1 thumbnail of distance for the other connector, so kind of have it down to a millimeter. I don't know what I'm fucking doing, man. Yeah, pretty much. Fuck it. Now, we get those gray connectors. Those are not gray. Those are the black ones. I need the gray ones. Where are the gray ones? There are the gray ones. Get 2 of those gray connectors. And fuck, I think I opened one yesterday. No? Okay, fuck it. Open the gray connectors. And we're gonna put the gray connectors on the wires, and that will be the power supply side. So my naked wires are here. Put that shit in. I think I got a message. I'm sorry. Put that shit in there. It doesn't go out on the other side, which is exactly what we want, but you push it as much as you can. And it's another crimping tool now, one that cost me about 10 times less than the one I got for today, because this is Knippix, and this is random ass Chinese crimping tool company, Incorporated. Still does a great job though. Connector, extremely stable, extremely safe. Professional grade, military grade level encryption, post quantum resistance encryption. I don't know what the fuck I'm saying. There we go. And crimped. Now, what we're gonna do is we are going to crimp the other side. To crimp the other side, the same shit, back at it again. Whoa. Way less this time. I think it's too little. There we go. And then we need the spade. I think they're called spade terminals. I'm not completely sure. I'm pretty blurry on the naming of all those things. I know what they are, I just don't know what they're called. If you mention them, I could recognize them, but I can't like come up with the names myself. I just don't care enough. Too cool for school, baby. Okay, yeah, there we go. Let's put this shit in. Put it right there. Wimp. Pull on it. Very solid, very pretty. Yet again, another work of art. And put it in there. Very precise. Quimp. Quimped. Pull on it. Fuck, they're all not precise. What the shit? Is it the right size? For 1.5 to 2.5 millimeters squared. This is literally... I crimp wrong. Why did I crimp wrong? I didn't crimp enough, that's for sure. There's quite a lot of space. Well, I mean, I can just take the other ones. I got a couple more. One, two. Now, it would be fucking dramatic if... Because the ground looks solid, but maybe the ground is not solid either, and the ground just gets disconnected and the rest stays, and just everything burns in flame. I fucking love electricity. Maybe I'll get a bit more naked wire to work with, because that might be why. Yeah. That might be a bit better. Let's try. Let's really stuff it in there, you know? Let's really try to like twist it to make sure that everything goes in, and then fucking push it in there as hard as possible. As hard as possible. Place it very properly in there. Yeah, there we go. Trying to make the cleanest job possible. Really push that shit in and just like, no, that was not good. That's not good. That's not what I wanted to do. Fucking hell, I'm just doing bullshit. Give it 2 clicks. Try to get as much wire into it as possible. There we go. Try to get as much tension, surface contact, and fucking put that shit in. I think we're good. Let's look. Please don't. Why do you hate me? Like, what's wrong with it? Because this one is solid, you know? Yeah, this one is solid. This one is not going anywhere. This one, as soon as I tug on it, maybe it's because like the inside is like just a bunch of very small wires, and the other has one. Hey, MG, what's up? Yeah, still alive. Well, I haven't done any of the AC yet. I missed a crimping tool yesterday that I had to go get, which set me back because of your people, because it's made in Germany. It set me back 108 euros. I didn't realize until I paid, and then I was just too socially awkward to just say, you know what? No, I'm just gonna go to that other shop that has regular Chinese hardware. And so I ended up spending pretty much my yearly allowance on this, which is fine. But I haven't done the AC stuff yet, and I'm starting now. And those connectors are giving me a hard time. I don't know why. I don't know why. They're a bit shitty, to be honest. But yeah, that's what's going on right here. Okay, let's try again. If I believe hard enough, this one's gonna work. Or maybe I should just crimp it on the other side. We'll see. This is my last trial connector. From now on, they are very serious connectors. Crimping around the neck just gives you 10 plus strength. You know what? Let's also crimp it in the red. Now that shit's not going anywhere. Epic, yes. Okay, there we go. That was the trick. It was crimping with the red. Yep, not going anywhere. Okay, yeah, that's good. So even if they're blue connectors, you crimp in the red because even though it is a German-made tool, they didn't measure correctly. Yeah, it's color-coded, but still. Still. There we go. Fuck that. Put it in the red straight away. Crimp that shit to hell and back. And yeah, solid. Fuck it. Let's go. All right. So this is the moment you've all been waiting for, which is, am I gonna die when I plug it in or not? I forgot. Oh yeah, right, the cable. So the cable goes like this. So right is neutral. We did the testing yesterday with a multimeter, like a good boy. There we go. And then we have this fucker right here. Yeah, and those are all pretty fucking solid, which is exactly what we want, need, whatever. Then we're gonna connect that side into, so red is line. Line is the live wire. It's what you really don't want to touch. Where am I going? I'm going here. Yep, all right. Screw this in. To the power supply. You guys seeing this? Yeah, sick. Screw this into the power supply. Pretty tight so it doesn't go anywhere. That's good. And then screw this into the power supply as well in the neutral line. Because red is neutral for some reason, black is neutral for some reason. It was supposed to be blue, but you know how it is. I don't give a shit. There we go. Miss me with that. I don't know what I'm saying. Huh. What's up? Epic. Okay. This is all solid. This is solid. This is on 0. Right? I don't know how to do this to be the safest possible. Oh, I didn't put the insulation. Oh, there is insulation. No, but I'm fucking stupid. Like, there should be more insulation. I had insulation. I bought insulation on purpose. I should have put the heat shrink tubing, but I didn't. So, I don't know how the fuck I'm gonna do this. Yeah, I don't have any insulation on that shit. I should have. I could put heat shrink tubing, or I could put fucking electrical tape. Electrical tape looks a bit shitty, but it might be safer. Let's check. Whoop. All right. I should have electrical tape somewhere. Maybe I don't. And if I don't, it's okay. And the heat shrink tubing is downstairs. So for now, you know what? Let's fucking raw dog it. Again, I might die. It's fine. Lived a good long life. Make everything straight. And I have a cable right here. Whoop. And it is on 1, right? So what I'm gonna do, I'm gonna try to not make this fall. I'm gonna plug this in without touching anything, right? So I'm going to plug this in, not touch anything, and if it works, you should see an LED pop up in there. This green LED, do you see it? You don't see it. Okay. I'm gonna put everything here. I'm gonna put this on there. There we go. Okay. If it works, this green LED right here will show up. Where are you connecting? Oh, you're connected to this. Ah, shit. Okay, I don't have a plug. Do I have a plug? I might have a plug. Okay, yeah. Unplug the computer. Plug this in. Not touching anything. The LED's on. The LED, it's on. It's on. Yeah. And so now, I'm really scared of touching that little metal box. So instead what we're gonna do is we're gonna take the multimeter and we are going to check for the 24 volts. So I put myself as 200, one on V plus, one on V minus, V minus, V plus, and the reading is 24 volts. If I take it off, 0. Then if I go to alternative current, 600 volts of alternate current, I should be able to read 245. 245 input and 24 output. That's good. And now I want to see if there is actual continuity on the box. So continuity on the multimeter, you can put something that is continuity. And if it goes, if there's contact between two surfaces, it will read it. So obviously a metal is conductive, wood is not conductive. Those are conductive between each other. So I'm going to put them on the box. So the box itself obviously is conductive, but if I do, I'm not sure what I'm doing, to be completely honest. I kind of want a reading. I just want a reading. Is anything going through the box? Yeah, we have 1 volt. No, the box has 0. No, the box literally has nothing. So the box is safe to touch. Yep, just not the terminals, obviously. But anyways, we have AC to power supply, all safe, all grounded, which is really cool. I'm going to turn it off now though, because the terminals are exposed and I'm a bit terrified of those. There we go. Turned off, unplugged. I'm gonna go pee and I'll come back and then we'll do power supply part 2. Are you making a government project or what is this? Yes, sir. We are talking government, we are talking institution, we are talking attractivity cell of the Principality of Monaco that is looking for stuff to represent the Principality in a bit of a fancy little way. And my fancy little way, I'm gonna make you a breakdown actually, since you're here. I'm gonna do a little breakdown. Ooh, wow, there's still currents going through this. I'm gonna die eventually, it's okay. I'm gonna make you a little breakdown. It's breakdown time. Okay, so what we're doing is this render on that side, this little render over there, that's gonna be a big ass table, 90 centimeters high, 1.5 meter long, and around 80 centimeters deep. That whole thing is going to be filled with those cuboids. So they're rectangles, but also cubes. That's what they're called apparently, which are sanded in different ways so that when light comes from under, which is the plan, we have a bunch of LEDs coming from under, it's going to show in a bit of an Apple Tim Cook style, a little Apple sucker time. And when there's an event going on in any place in the Principality, in fucking Monaco or whatever it's called, that place is going to shine a different color. It's going to make little waves, go whoop, whoop, whoop. And the idea is that it looks fucking cool and you can put it in fucking institutions. You can sell it to government agencies. I don't really know. I have a couple plugs. We'll see how it goes. But we have so far made this, which are little fucking cuboids. This whole thing of acrylic PMMA cost me around 160 euros. That's 50 centimeters of PMMA. Because I didn't go for a nice, cool supplier that sells them for cheap. I wanted them fast to prototype and to test the post-processing. And so I bought them extremely expensive, but I have a couple meters that are coming from Paris that I paid pretty much a third of the price. Even less, a fifth of the price. And so in a couple days, it's actually coming tomorrow around lunchtime. We're gonna try to find a place where we can cut them into their desired height. And talking about the desired height, the map, so the project, is also going to represent the height around the city. So every point is going to be around, I haven't made the calculations yet, but maybe 100 meters by 100 meters, maybe less. So 100 meters squared. No, that's too much. 50 meters squared, I don't know. And every point on there is going to have a certain height, and we're going to merge this aggregate this into a mean, and then every cuboid is going to be the height of that space, which I think is pretty fucking cool, man. And so yeah, very cool stuff. Are you using it to control ESP32? Whoa, yes, you have a lot of fucking questions. Good things I got the answer. The way this is going to work for the brain, you got a Raspberry Pi 5 that's going to be connected to internet. So I'm gonna have and maintain a database of all the events that are happening with the dates and the coordinates on my map. And this Raspberry Pi is going to talk to two ESP32s with Ethernet ports, and everything is going to be connected within the table. So under, I'm going to have a steel structure connected to that switch with Ethernet, so that they can talk without any delay. And because I have around 15 individual LED channels that are going to be powered by those big power supplies that we were working on earlier before you came in and I did a little breakdown for you. Since I have at least 15 channels, I needed to split it between two different ESP32s. I think I'm going to alternate, and I'm going to have a matrix XY coordinate system. So a plane, and if stuff happens in 200, 200, then from 200, 200, the radiation is going to come out. I don't know if you have the vision. But yeah, ESP32 as the muscle, and Raspberry Pi 5 as the brain. Yeah. So let's get back to it. There is. So yeah. So we have done part of the AC. Now there's one thing I haven't thought of, which is, oh yeah, right, yeah. I'm not gonna. Yeah, there we go. That's what I wanted to talk about. Since there is a lot of current and a lot of stuff that's going to happen, and I have two 15 channels. The amperage might be too high if I power everything from one singular power supply, because this can pull out 350 watts max. What we want, however, is to have, I think I did the calculations, and we're above 350 watts. Plus 350 watts at 24 volts is too much amperage, so we have two power supplies. And to have two power supplies, I need fucking Wago connectors. Now, Wago connectors, I think you can just give them bare wires. So those connectors are superfluous. And I think it takes AC. So, 20 amps, 300 volts. Sick. So, we take everything that we said back, and we are going to so unplug those. Hopefully they are now crimped good enough so that I can just fucking unplug them like this. It's a bit of a hassle, but yeah, there we go. Two. I should have disconnected the line first. 2 and 3. Jesus fuck. No, the connectors blew off. Ugh, what a fucking nightmare. Well, yeah, Wago, you can connect any wires and it's so reliable in my experience. Yeah, I've been using Wago, but mostly for like low voltage. Well, this 240 is not super high voltage, but a very low voltage DC current, like 5 volts, 12 volts. They're so fucking cool that I ended up buying like this big ass box of them because I really liked them. I even contacted them because the whole YouTube channel, like the color is pink. I wanted to see if I could get custom pink Wago connectors, but they kind of never answered. Anyways, so the connector's blue, which is fine. We can just add another one. I think I have one last one because I fucked up those connectors earlier. The crimping of those connectors is a fucking pain in the ass. Yeah, there we go. What do you do? Since you've used Wago connectors, I'm guessing you have electric background. I would like to know more. Tell me about yourself. Otherwise, I can only talk about wires. Yo. Okay. There we go, crimped. Yeah, relatively solid. Yeah, and just split that shit. So I'm gonna take off the connectors from there, and I'm gonna put them into Wago connectors, and then the wires that come out of the Wago connectors, those are going to have those long connectors so that they can screw in very safely into the power supply, and we don't have any power leakage. Especially, it would be a shame to have power leakage at this voltage because this fucking zaps you. I've never been zapped though. I think I should try. I had, oh yeah, there we go. A screwdriver. Whoop. Ratcheting screwdriver. Ratcheting screwdriver. Oh wait, I have another possibility. Oh no, because I crimped it already. Fuck it. Oh no, nothing. Jesus Christ, the pie. That's all good. Yeah, I'm working on a simple smart home system. I'm thinking ESP Now, but I don't know if this range will be enough. ESP Now is fun. What did I do for ESP Now? Oh yeah. ESP Now, if, I'm gonna advertise myself. If you go on my channel, there's a video which I edited for, like, it took me fucking weeks to edit. Anyways, there's a video where you have, okay, let me explain that. You have a little ankle thing that has a voltage increaser inside of it, which means that it pulls out like 10,000 volts, so a small transformer, and you have wires connected to your skin, obviously extremely low amperage, so it's not dangerous. And I made a board with buttons, and so you pull up and you go hit the buttons on the board, so it's like a training little setup, so pull up like feet not touching the ground. And if you mess up or you take too long or whatever, you get fucking zapped. And the communication for that was ESP Now. So the ESP32 that's in the ankle thing and the ESP32 that's in the board are communicating exclusively through ESP32, which was a lot of fun to do. So for a smart home system, it depends how big your home is, but I don't think how that would be a problem. And it also depends what you want to do, because any other pre-made solutions have failed. Huh. Well, if you want wireless, yeah, wireless, you might need ESP Now, because wireless is a bit fucking annoying to work with. But if you are okay to do wired, you can do, like I'm doing with the switch, you can do UDP, you can use, you can set up a web server. You can have, if you want ESP32s controlling your appliances, I'm assuming that's the gist of it, you can set up a web server on like an old computer or a Raspberry Pi, and you make the ESP32s connected to Wi-Fi or Ethernet if you want wired, and interacting with that web server. I'm thinking what's the name of the thing? MCCP? Is that what it is? No. There's another protocol that kind of works. MQTT. Yeah, MQTT. Have you looked at new MQTT? Which is a, let's check that. Which is a simpler messaging on the TCP/IP protocol. It's relatively small messaging, queuing, telemetry transport. It's for smaller packets, but I think it has less. How do you call that? Yeah, MQTT. There we go. Well, then I'm guessing that you've already checked it and it didn't work. Because I've heard that it works pretty good. Yeah, there we go. Yeah, just let me know. Where was I? Fuck, I got too involved in this conversation. Now I lost where I was going. Oh yeah, taking off the connectors. All right. No, I'm only researching right now before buying other components. Oh, okay, all right. Okay. Shit. So, like, what's the goal? Like, why are you controlling with ESP32s? Because if it's like small things, like you could even use it's relays. They're relays, but they're relays that you directly plug into the Ethernet, and they have their static IP, and then you can just send like a curl or a get message or a post request to those relays through their static IPs, and that's really simple. ESP32s, you might need like wired is generally simple. ESP32s and ESP Now, you might need it if you do more complex handling. Because if it's just turning off a light or, I don't know, putting down blinds, a relay could do the trick. Thing is, wires isn't an option because it's 50 meters away from my home. Oh, okay, yeah. 50 meters. I don't think ESP now can do 50 meters. 50 meters. No, maybe it can. Maybe it can. I don't think I've done the research, but maybe it can actually do 50 meters. Yeah. Well, check if it can. If it can, it's not a bad idea to use ESP now. Let's someone get 800 meters by ESP now. Okay, yeah, well that sells it. Yeah, if you can get 800 meters with that shit, yeah, then fucking go for it, man. Fucking go for it. 800 meters. Yeah, but the conditions must have been perfect. Because 800 meters is crazy talk. Ah, shit. Ta-ta. 800 meters with ESP now. Jesus Christ. I was stressed when I was doing stuff like 50 meters away. 800 meters is batshit crazy. Okay, we're waggoed up. Yes, sir, we are waggoed up. Now, the waggo is going to live, so the setup is going to be something along the lines of... Jesus, it is a mess already. I started an hour ago. How long has it been? An hour and 20 minutes ago, it's already a mess. The setup is gonna be like this. 2 PSUs back to each other. And then the fuse boxes are gonna be here and here, basically. Which means that if I have the waggo connector, so the waggo connector coming in here, let's say, I think it would be interesting to have it in the middle, maybe on top, or maybe connected to the, maybe connected to the structure. So we're gonna have this big ass structure. I'm just trying to measure the distance that I want. Yeah, I mean, fuck it. Let's do, what is that? 50 centimeters? That's right. Yeah, let's do 50 centimeters. And if it's too long, I'm still in time to cut it, which is great. So we want to do that for ground. Anyways, ground is going to need to be super split. Because ground, we're going to need to ground pretty much everything. The structure, the power supply, the structure, the power supply, the structure. Oh, that's 2 things. Okay, all right. Let's do 50 centimeters. We're gonna cut some wire, baby. I have nothing to measure, but it's all right. It's just a 20,000 euro project. You can just fucking eyeball it. Yeah, that's about it. That's about it. Snip. Do the same for red and black. We are golden. Oh, I actually have this lying around. Is this long enough? Close, but no. Red wire. Fuck me up. Here it is. Whoop. Okay. How are you planning to make the big structure itself? That is a great question. It's going to be wood. So the table is going to be wood, the outside part. So I haven't decided on the wood yet, but I know I have a wood guy. I have a friend that has worked with wood quite a lot, so I'm going to get some tips from him. But I'm thinking I'm gonna get 1, 2, 3, 4, 5 planks of wood, 2 for the sides, 2 for the other sides, and 1 for the top. Post-process it a shit ton, paint it white, and then somehow seal it or like waterproof it and make it really, really resilient. And then under that, I have ordered around 5, maybe 6 meters of X extrusion. So those big fucking I'm gonna show it to you actually. X extrusion. You might have worked with it because it's pretty common in projects. Desk. So these fuckers, right? I have ordered around 6, 7 meters of those, and I'm going to mount everything onto this, right? for a start, at least. That will be for the first part of it. And then I have another friend, which is a steel worker. And I'm thinking of actually doing a really sturdy steel frame because the wood is going to need internal bracing, right? So the top layer is going to have holes inside for all of the cuboids. Actually, let's go back to this other scene. Whoop. Right, all of the cuboids are holed. There's holes for all of the cuboids that I'm going to do with a CNC. And there's a support structure for the cuboids under, right? Which is something that I have already designed. So those little supports, they only support the corners because the diffusion of the light needs to be as important as possible. So I want the light to hit the sides as well and the under. So I only support the corners. And this is going to live under the wood, but still that wood is going to be relatively heavy. And there's also a metal plate. So you see right under the cuboids is this metal plate, which is, I have a contact for a laser cutter. So it's gonna be cut out of 2mm steel with holes for the cuboids as well, which are gonna match the ones that are in the wood. So it doesn't really need to be tied together because the cuboids are gonna be like the how do you say that? The things that make it that it doesn't move onto one another, right? But still, this is all going to be heavy, so I need internal bracing. So the X extrusion, even though it is very good for prototyping, I'm going to be able to adjust the height of the layers. I think an actual solid empty steel tube frame with like this kind of tubing, right? And basically for the 4 feet, and then welded onto it some other tubes to support the layers. And on top, some sort of bracing. So it's exactly the same height and some sort of bracing that comes from under. So it releases a bit of the tension of the wood. Because the wood, I'm not sure it's gonna be strong enough to support everything. I haven't done any calculations. I'm not a fucking engineer, man. But, well, at this point, the electronics seem simpler in the structure. Oh yeah, oh, the electronics. This is the simplest fucking part, man. This I know how to do at least. The wood, I'm not sure. The X extrusion, I've worked with it a bit. I can do a bunch of like 3D printing. Got a 3D printer over there. Maybe this camera can hit it. I have a big ass 3D printer. If you look, it should update. Fuck that camera, man. Come on. Come on, buddy. Come on. No? Well, you're not gonna see it. Anyways, I have a Bamboo Lab H2S, which is relatively big, so I can do quite a lot of yeah, there we go. I can do quite a lot of 3D print with it that are going to be the connectors for every part of the X extrusion. So I don't know if you've ever worked with those, but you can just screw in a couple plates and then those plates are gonna hold them in between with each other. So that's the easy part. Then the steel part and the wood part is gonna be a bit trickier. But you gotta do what you gotta do. Where's my wire? Oh, that's the one. I was cutting the red, right? No, I didn't need to cut it. What the fuck am I doing? Oh no, yeah, I'm cutting for the Wago connectors. Right, there we go. That was it. Since I'm going to split it, oh, I'm going to split it 3 ways. The input and 2 outputs. So I need 3 of those. But yeah, the structure is a bit of the worrying part. I don't have enough space here as well, so I'm looking for a workshop to be able to work onto it. But I started the project, this is day 4, so it's been 4 days. I have gotten all of the electronics. I have already a supplier for the acrylic. I am looking for I'm looking for nothing. I'm just waiting for stuff to arrive. Yeah, I'm looking for a place to cut the acrylic. I think I'm gonna buy a big melt saw. We'll see how that works once I have the workshop. It's gonna be fun. It's gonna be fun. But yeah, this is like the biggest project I've ever done. Again, advertising myself, but if you subscribe to the channel and if you check out the videos, they're mostly like smaller projects. A bit more in the fun part. They're a bit fun. They're a bit goofy. But yeah, this is the most second most serious project I've ever done, which is cool. It's cool. There we go. And another one for ground, and we're good. Woohoo! All right, buddy. Doing a lot of wiring at this point, huh? Wiring's fun. It's not wearing at all. It's not fucking miserable. I'm not having a terrible fucking time. There we go. Okay, and now a bunch more crimping, which is good. Because for those who haven't seen, this is the crimping tool. I got that shit today. We were missing a crimping tool yesterday. I went to the hardware store. I wanted a crimping tool. I expected to pay 20 euros for it, but it turns out the fucking Germans decided that they wanted to do crimping tools too, made in Germany, and they decided that it should be priced 183 euros. And I decided that I wouldn't see the price until I got to the cashier, and the crippling anxiety would make me just say, yes, I'll take it. Anyways, the view from your apartment is crazy. Thanks, bud. Thank you. How do you see? Wait, what do you know? How do you know who I am? How did you see the view? Oh, it was the camera when I would show the printer. Yeah, it's pretty fucking sick. But I'm trying to move out of here because this is not my place. I have lived in the Netherlands for quite a while, and I came back here to be closer to my family and shit. But this is not my place. I'm trying to get my place. I came back like 5 days ago, but I'm already looking for apartments. But it's not gonna be as nice when I get mine. I'm also looking for a workshop to separate life from work. Okay, splitting here, black, stripping. Lol, my dad just gave me an RGB controller to fix. What the fuck is an RGB controller? Oh, is this like those LED controllers? Is that it? Like you just plug your, are they called SDI or something? You just plug your LED inside of it and it just does the job by itself. You don't have any coding to do. Is that what you're talking about? Those are fun. I've never worked with those, if that's what you're talking about. RGB controller. Yeah, that must be it. Yeah, all right, 2. Did I strip the other one, or I'm a lazy piece of shit. I haven't done jack shit. Where's the last one? I had it in my hand 2 minutes ago. I'm clinically insane. Yes, it's a Wi-Fi RGB controller. What the fuck does Wi-Fi RGB controller stand for? What are we talking about here? Wi-Fi RGB controller. Oh yeah, that's it. Oh, that's fun. DMX, right, DMX. DMX. That's some fun shit. Yeah, I don't think you have any coding to do with that. Like you can just, is it WLED? See, German again. Oh, you're gonna, that shit must be pricey. Oh no, 29. Yeah, no, that shit is fun. 12 to 24 volts as well. That's pretty cool. I could have used that, to be honest, for my installation. But yeah, no, those are fun. How do you repair that though? Like the PCB inside, can it fucking blew it, or what's the holdup? Nest. Hi. I lost the cable. I had the cable in my hand 3 minutes ago. I lost it? Oh no, it's here. Oh yeah, buddy. Okay. Strip it. I mean, it might not be broken at all, but apparently it could be fried. Oh, that sucks. I mean, do you have any training as like electrical engineer? Because fried stuff, you give me something that's fried, I could not fix it. I know a bit, like enough to do that kind of shit, but as soon as it gets like to a certain level of small, so we're talking like PCBs and shit, dude, I could not do that shit. I'm 14. Sorry. Okay. I'm not mugging you. It was very unexpected. I'm 14. I got element. Okay. It was very unexpected. Yeah, no, fair. Okay. Yeah. So I'm guessing PCB design and repairing is not going to be fun. Yeah. Oh yeah, one more connector. Yeah, no. Then if it's fried, I don't know. Fucking, I don't know. I gotta go to some specialized electronics school soon. Oh, that's fun. You got those? I mean, can you do that when you turn 15? Like, what is it, 15? High school? Can you go to electronics school at 15? They teach repairing there. That's fun. Mostly like DC appliances or big ass AC circuits. Whoop, whoop, whoop. Okay, one more crimping. Oh, you're in Poland. Okay, we have middle school at 15 and you can go to those schools that teach electronics. Sick. That's pretty cool. If you know that you like it and it's a good school, I mean, why not? Hey, your English is good for a Polish person. Shit. Electronics school, yeah, that sounds fun. I mean, if you know that you're passionate about it already, that's fucking cool. You know, most people don't know what they're passionate about until much later in life, if at all. Yeah, go for it. Electronics school, hell yeah. I need more? Oh yeah, true, it's a one thumbnail thing. It's only 40 plus people that can't speak. 90% of young Polish people know Polish. English, I'm guessing. Really? I had zero idea. Well, the closest country to mine is France, and approximately like, I don't know, 90% of young French people can't speak English. So I guess you have a good education system. Props to you. I've never been to Poland. Maybe I should. I've heard that Cracovia is pretty. That's all I know. Where's the other connector? I fucking lose shit all the time. I'm going insane. I mean, if you got the people under 40 that are all learning to speak English in this generation, that's pretty good for the country. Like in terms of future expansions, that's gonna be fucking sick. There we go. Okay, everything's crimped. Everything's crimped. Sick. Which means that we can now, okay, that was just the neutral. Now we need to do line and ground. Give me a bit of work. So we're gonna do the same thing with line and ground. So I have one ground line here, ground wire, two ground wires. Gonna have to put them in their own little Wago connector. Did I fuck up? No. Okay, all right. Wago connectors. Vago. Oh, there was the connector. Now, where the fuck is the Wago connector at? Shit. There we go. One Wago connector. No, it's not super solid. Oh no, it's fine. It's fine. No, Wago connectors are fucking sick. I love Wago connectors. Everyone should love Wago connectors. They're the future. Fuck soldering. Shit. I don't love Wago connectors anymore. I'm over it. Okay. Hey. 1, 2, and the input. Right here. Actually, I said that you can't use those connectors for Wago connectors, but maybe you can. Or maybe I'm gonna break it. It's okay, I have like 25 of them. Oh no, you can't, it doesn't fit. Alrighty. Alrighty. Ice cream is so good. Ah! Jesus fuck. I'm putting shit everywhere. All right, gotta go find a 12-volt power supply. Good luck with your project. Thank you. 12-volt power supply. I hope you can repair that RGB connector. That sounds like a fun little project. More. That's maybe too much. We'll see. Connectors are fun. Wait, is that connected? Oh wow. Dude, Wago connectors fucking break my brain every time. Everything's reliant on this little fucking brick over there. Okay, that's 2. Where's the first one? I think I'm holding a balloon. Where's the first one? Okay, first one is here. Second one is here. Okay, this one needs those connectors. There we go, that's what I was doing. And we said approximately 1 thumbnail worth of naked wire. We are stripping wires for the people that just came in, YouTube or Twitch. Stripping wires for this giant installation that we're currently working on that is in the bottom left of your corner. That's the other side. Wait, oh yeah, no, that was right. No, that was, okay, bottom left of the corner. We're doing the electronics part of it. So a couple days ago we did the cuboids that are going to be lit from under by LEDs. We are going to be doing the structure next week. It's gonna be a big ass table, 1.5 meter, but 80 by 90 high. And we're doing the electronics. So we have fuse boxes, we have power supplies, 24 volts. We have a EMI, electromagnetic interference filter somewhere. And we're doing the wiring. So big ass wires because we are dealing with quite a lot of current in some of those parts of this circuit, especially coming into this fuse box. Since those can pull out 350 watts at 24 volts, that does quite a bit of current. So AWG14 and fuse boxes for safety, right? So right now I'm just crimping a bunch of wire with this beautiful, beautiful tool that I bought today, crimping tool. And I need the gray connectors. I don't know where the fuck I put them. It is a mess on here. Okay, there we go. That's what I'm looking for. Whoop. Shit, there we go. Yep, that's what I'm looking for. And crimp those fuckers. Crimp 1, crimp 2. Pretty much at the exit, which is great. Go in the hole. Crimp it. Go in the hole. Crimp it. We are crimped. That is a Wago connector. And yeah, sick. All right, next. And finally, we have the red line. So, wait, I should have cut the wire already. I just don't know where I put it. That's one. Did I cut a second one? I should have cut a second one. Is that the right length? It doesn't look like the right length. So the long one is this one. Is it the right length? Yes, it is. Okay, great. So that's one. But I think this one is not the right length, right? No, obviously not. So this is just like a throwaway that I might use later if I need cable of that size. And let's cut a second piece. Unless I've done it already. I feel like I've done it already. Oh yeah, there it is. This is the right length, right? It's not. What the fuck? Oh, it's not the right length at all. Shit, okay, so I have two throwaways. Really? That sounds wasteful. Oh, it's fine. Okay, let's cut a second one. Number two, number two, number two. There we go. Same length. Snip. Circumcised. Then get that wire hot and bothered all the way to the point, all the way to the point where it's naked. Okay, wait, no. This is the size that will go into the Wago connector, so not too long. And well, a bit longer than that though. No need to be prude. That goes in there, and then the side that will go into the crimper, approximately this length. We are golden, and I need two more of those gray connectors that I keep fucking losing. I don't know where it is. I'll find it. Wait, where's the interior camera? Oh, it died. Yeah, it's the prototype camera. There we go. Hey. Hey. Okay, epic. I'm going to turn on the light. It's starting to get dark. D-A-R-K. Okay, that's a bit better. Okay, so. We'll go way too big. And we start the camera. And yes, there we go. Crimping. Gray connectors. There they are. I need two of you. Two of yous. Camera didn't restart, did it? Oh, the entire stream crashed. Oh no, there we go. Hi. Okay. One of you. Oh fuck. Goes in there. Sick. Second one. Goes in there. Double sick. And we crimp both of you fuckers. So that you never go away. You are now stuck for life. That is some professional shit right here. And the rest goes into a Wago connector. Wago! Wago. Right in there. Right there. Thank you very much for coming. You may stay there forever. A bit thicker. There we go. Number two. Number two. Hey, that's fun. Fucking love Wago connectors. They're the future of electronics. And let's go for a number three. The number three is going to be the input. So we have the input line wire. So that's part of the AC circuit. So this is the red line wire. We have to remove this connector because I fucked up earlier. That's why I am making those specific wires. But cutting this shit with the insulation is a nightmare. 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 I don't know which one is the British and which one is the American accent. Anyways, whoop, in the waggle connector. Down we go. Down the hatch. Eat it. Eat it through the jeans. Okay, there we go. Nice. Okay, so we have all three. One that's line, one that's ground, and one that's neutral. And that is looking sexy as hell. Why do we need that? Simple. When you asked that earlier. Because we're splitting. I'm gonna kill myself. I know what this was. I knew I didn't have two throwaways. It was this. One of the wires jumped out of its connector. I'm scared I did a bunch of bullshit. Which is a possibility. It's always a possibility. I think people just do. I don't know what I'm saying. I'm getting stressed, man. So one of the connectors that went to the fuse box, which would lead the power supply to the fuse box, was a bit loose apparently. I didn't crimp it properly. So it decided to jump out of its connector. Great choice, great choice. I would have done the same. Now the problem is I only have red connectors now, which is fine. It's all right. I can just crimp the red connectors, which are supposed to be for smaller wires, but fuck it. Oh, I know why. I know why. Little bastard. I cut a little too much. So I cut half of the actual important part of the wire, so it didn't have enough stuff to like grip onto. So I'm gonna do a new red wire, because safety first, man. This is a professional installation. If safety is not first, people will die. Now I generally tend to be pretty fond of people dying, but not when it's a professional project. Okay. There we go. Boop. Snip, snip. Circumcision for you. We need 1 thumbnail worth of wire to be able to put the connector onto it. And here we need to do a ring terminal, which takes way less. So ring terminal we do. Take that shit. I'm gonna sit down. I don't know, I'm standing up. Ugh. Yo. Okay. Hoop. Connect that shit in there. Yeah. It should be going on at some point. If you're convincing enough, it will go in. Yep, there we go. Boys, we're in. Okay, and whip. Expensive crimping tool. Very expensive crimping tool. A lot of precision is going into this. Attention. Whoop. And now we are safe and secure. That was not the right one. This one's not gonna fit. Oh no. Oh no. In terms of length, how are we? I can reuse this, fuck it. Yeah, I'll reuse it. Oh no. I keep doing bullshit, man. I keep doing mistakes. It's the stress. It's the stress, man. Stress is not good. I keep doing mistakes. Oh no. Okay, let's cut it. Let's get it naked again. A bit more. A decent amount of naked. And let's take a connector. One that works this time. Put that in there. Really tie it up. Okay. Put that crap in there. Bleh. Bleh. Eh. Yeah, all right. Crimp that shit. Quimped. Whoop, circumcised. Solid, extremely solid. Maybe the most solid thing I've ever seen. Out of all the things that I've seen, I think this one is the most solid. And I think I've seen solid things, but this one is the most solid. Out of all the things. If you take all the things and you look at them, and there's one thing that you say, oh, that's solid, it's this one. This one is like the most solid. Like you take all the solid things, all of them. Fucking diamond, fucking stone, wood, obsidian, bedrock. That's the most solid. This crimp, the crimp of this wire, that's the most solid. Out of all these things, more than bedrock. You can't break that with a diamond pickaxe. Is what I'm saying. Like, it's what I'm trying to say. I mean, if you're not following, yeah, it's all right. But if you are following, it's the most solid. I'm having a psychotic episode. All right, so now that this has been repaired with a lot of focus, a lot of convictions, a lot of love. What the fuck was I doing? Oh yeah, so those two are throwaways, right? I do not care about those. I have, however, my Wago connectors. Yes, there we go. That's where I was. My Wago connectors with the spade connectors that are a bit janky, but still pretty strong. Reasonably strong. That looks reasonably strong. And that looks also reasonably strong. Yeah, we should be good. Now, the idea is the plug that I was using earlier is this one. Boop. We are going to connect this to the power supplies. Average view duration 25 minutes. I'm just looking at my fucking stats now. I have been streaming for a grand total of 2 hours. Okay, it's been 2 hours. 2 hours is a reasonable amount of time to be working. Okay, this goes onto the ground. I should be putting, insulation, but not for now. Now, we ball. Okay, and then left is for line. Left is for line. Line, I decided to be red. Left is for line. Let's double check that accusation. Not to be mistaken, the cable is showing that right is for line. Interesting. Yeah, I'm completely wrong. That's fucking sick. Right is for line, and left is for neutral then. I think this makes sense. Whoop. There we go. So now we have the Wago connectors that are connected to all of those things. So this is going to be ground. So I need to screw everything in. I think I have something around my neck. A random ass red cable. That makes sense. Now, we are going to, ladies and gents, take a screwdriver, unscrew literally every single pin, input pin. I'm putting shit everywhere. It's all right. Okay, every input pin, which means line, neutral, and ground. Whoop, whoop, neutral, and ground. We're gonna take our ground first. Put that shit right in there. Jesus fuck. Come on. Yep, okay. I mean, it's sticking out a little bit, but it should be fine. Number 2 also goes into ground. Now the goal is that nothing explodes. If nothing explodes, we are halfway there. The annoying part is when stuff explodes. That's a bit trickier to handle. The ground is the one that you really don't want to untie, because then everything can shock you and you can die. Then we're gonna take the line. Input. Input is important, because if it's the output that we connect to the input, then it doesn't work. The line input is going to be at the end of a Wago connector. I'm not sure where that Wago connector is. It's here. Hi. Whoop. There we go. We stuff that motherfucker in there. As much as possible. And then screw it back on. That's fucking safe. That's fucking safe. That's fucking, oh shit. There we go. And take the other one, put in the other power supply. Whoop. Now you might say this is some messed up wiring that we have here. Nah, I say the opposite. I say you're messy, and the way I'm doing it is the right way. If I die of electrocution, you will have the right to be right. But until then, my way's the best. My way being not really sure what I'm doing, but doing it anyways. And then last but not least, neutral. Whoop. Yeah, let's do this. What does that mean? Interesting. And that's what it is. Okay, sick. What was I doing? I forgot. Oh no, yeah, right. Jesus, I have the attention span of a fucking monkey on crack. Yeah, this one. Okay. Right, this is over, so this should be over, and it should be pretty much at the same. Swoop. Oh yeah, but when you're going there, you're going there. Yeah, I have the attention span of a monkey on crack. And that is a euphemism. I actually, it's worse than that. Okay, now we plug it in and we see if it explodes. If it explodes, it sucks. If it doesn't explode, it sucks even more. I'd kind of like it to explode. It would be fun. Everything is Wago connected. Everything is Wago connected. Everything is plug connected. And everything is Wago connected on the third. Where's the third? 1, 2. 1, 2, and 3. Right, everything is Wago connected. Now, what we want to look for, use your little peepers and you check if this green LED is turned on and if this LED is turned on. I'm going to turn off the light so we can see them better. Right? Okay. If it blows up, don't panic. I'll be dead, so I can't do anything, but it shouldn't. Are we green? We're green on both. That is a great start. Next, we will do a bit of multimeter time. Whoop. So, now let's be extremely careful because a lot of those are exposed. I didn't put any insulation anywhere. So, let's check for the 24 volts continuous on the output. Plus and minus should give 24 point something. 24.2. Take it off, nothing. Now, next, plus and minus should give 24.2. Fucking sick. Okay, both power supplies are working. The connections are somewhat secure. I don't have any insulation on exposed 240 volts terminals, which is, some people would say dangerous. I said exciting. It's exciting. So maybe I should put some insulation, but fuck it. No, we're good. There's literally nothing going down through the encasing. So the encasing is safe to touch, the terminals absolutely not. The encasing is grounded. All right, let's turn it off. Let's wait for the LEDs to turn off. When the LEDs turn off, everything will be safe again to touch. I'm also going to unplug it just to be safe. There we go. Everything is unplugged, everything's safe, everything is triple safe, almost. Still waiting for the LEDs to turn off. I'm gonna pee in the meantime. Bye. Oh, Jesus, didn't open it properly. Oh, toilets are hard to use. Oh. And then we connect the fuse box. The fuse box. Yeah. I want to connect the fuse box. I'm gonna put the fuse box and connect it to my power supply. Yeah, my power supply. Yo, sick. I need some water. All right, hi. I'm gonna get some water. Ugh. Maybe coffee would be an interesting idea. How's the battery of the Mac doing? Oh, it's doing great. All right, so the idea is now to connect the fuse boxes. Okay, the LEDs are turned off, which means it's kind of safe to work with. I hope. No, I wish I had some electric tape right here. I think it's downstairs. Anyways, we're gonna do the fuse boxes. Make sure that they're lighting up properly. And if they are, and when they are, we're gonna move on to coding. We're gonna do the Raspberry Pi and the ESP32. I have a way to flash the ESP32 even though you don't have a micro, what's the fucking name? Micro USB port. So ESP32s with it, that are called ESP32 Dev Kit are made for you to be able to flash them from a computer with a micro USB. The ones I have for those are like not dev kits. They're like for people that know what they're doing. So they don't have a micro USB. So the way that you flash them is with a UART to USB. I'm not even sure what the fuck I'm saying. There's like some sort of fucking USB stuff that you put in your computer's ass, and there's a couple wires that go out, and you can just flash it with those wires. I don't have this, so what we're gonna do is, in my pocket, I always have a couple of DuPont jumper wires, a bit more, and ESP32 dev kits. So those have the micro USB port. And so we're gonna flash the non-dev kits from the dev kit. We're gonna turn the ESP32s into converters, transformers. What the fuck? Adapters, there we go. And so we connect this to the other and we're gonna flash it through it. That's kind of the idea I went for. There's a way to disable the ESP32 chip and just turn them into regular adapters. That's what's gonna happen after we are done with the power supply. Fun. Okay, power supply into fuse box. So fuse box connectors are solid now. God bless. So we are going to do that. So each of those is going to be powered by one power supply. So let's do a bit of order in there, because it's fucking messy. That's what you do when you take off the insulation of cables. It becomes a fucking mumbo jumbo mess of wires and shit and insulation. Whoop, whoop, whoop. Cleaning stream. Yo, that's the new meta. That's the new meta. Okay. Okay. Almost done. And put the connector back into the connector fucking thingy. Where's the connector thingy? I don't know. I got a Wago connector here. I fucking love Wago connectors. Did I tell you I love fucking Wago connectors? They're just great. They're great. They're great. They're amazing. Maybe the best thing that ever happened to humankind is Wago connectors. Okay, this is just trash. Alright. So, connect those to the V minus through the power of love and friendship. V minus. V minus. One fucker. And two fuckers. And whoop. No, you stay in. Relatively tight. There we go. And I think I'm only going to do one today because I need another one for the video. I need to do it on video as well. And for the video, I shoot with this baby, the Canon R5C, and I kind of want to have some like good ass quality for the video. So I'm just gonna do one fuse box now, and then shoot the rest with a camera later off stream. This is for the V+. This baby. It's gonna go in there. Come on. And this baby, which doesn't have a connector for some fucking reason. Woo! I haven't done it. Yeah, that's fair. It's my fault. It's my fault. It's okay. I like crimping wires now. Now that I have all these tools. Yeah, buddy. Crimp. And put that shit in there. Put it. Come on, go in. Stop being a bitch. Stop being a bitch. Stop being a... There we go. Okay. Let's hope it doesn't blow up. And let's see if... What are we looking for? It should light up, right? No, I should just... Yeah, okay, that's what we want to do. I'm going to multimeter it. So, back at it again. Everything's connected properly. Yes, it is. The switch is on off. Yes, it is. And so we can put the switch on and hope it doesn't blow up. Do we have the green LEDs? We have the green LEDs. No power is being pulled, so the fucking, I don't know what the fuck is that. The fans are not running. But if I decide to use the multimeter, I should still see a reading of 24 volts on the fuse box. Oh no, because I don't have fuses in there. Oh, that's actually an interesting point. Okay, so the way this works, since this is a fuse box, if there's no fuse in there, the communication between the plus and the minus is not going to work, technically speaking. So if I find my multimeter and I put it in direct current, 200 volts, and I go from 1 plus to a minus, we still have 24 volts. That is really weird. Oh, actually 22 volts. And maybe when I put the fuse, it's gonna be different. Who knows? Let's try. I have those blade fuses somewhere. There they are. Those are the fuses. They look extremely cool. They're little blades. And so you... Oh, fuck, you don't see it. This is the blade, the fuse box. Little blades, and you just push them in. Like so. And nothing happens. But still, we should be getting 24 volts. Oh yeah, it's off. Oh yeah, no, because I'm going minus to minus, I'm fucking stupid. Yeah, 24.2, there we go. When there was no fuse, it was 22. So I'm guessing it's providing this just a bit of additional bridge. And when it's rushing over 10 amps, then it's gonna burst because it's a 10 amp fuse. Yeah, fucking sick. So we are already pretty far when it comes to this. Let's do some more. Let's power the Pi and the ESP32 with this. So let's clean up. I'm gonna clean up a bit. I'm gonna take a little break. I'm gonna clean up and I'm gonna come back and we're gonna do the electronics. The ESP32 and the Pi. All right. See you in a grand total of